Welcome to the deep dive. Picture this. You walk into a hospital ward. You can see the usual things, right? Clipboards, white coats, maybe a family looking a bit anxious. But listen closely. Hear that? A faint hum. It might just be a graphics card tucked away next to an imaging station and running on that black box. It could be MedGemma, Google's new open-source medical model. It's not chatting about the weather. It's focused on, well, pretty much the most important questions for a patient. What's wrong with me? And crucially, what do we do next?
Exactly.
So today, our mission is basically to give you the fast track to understanding MedGemma. We're going to unpack its architecture, its capabilities, and some surprising ones, actually.
Yeah.
We'll look at why being open source is such a big deal here and the privacy side of things, having silicon as part of the healthcare team. By the end of this deep dive, you'll get why people are calling it like the junior resident who never asks for coffee breaks.
It's a good analogy because MedGemma is really stepping into this massive challenge in healthcare, which is just the absolute deluge of data.
Oh, tell me about it.
I mean, think about it. Chest x-rays, skin slides, eye scans, notes, vital signs streaming in constantly. It piles up way faster than any human expert or even a team can possibly keep up with.
Yeah, it's overwhelming. And the older AI models, they weren't really up to the task, were they? They were very narrow.
Right. Very much one-trick ponies. You'd train a model maybe just to spot pneumonia on an x-ray. That's it.
So if you needed something else, like analyzing a mole.
You needed a whole new model, new data, new training, often new regulatory hurdles. It was incredibly fragmented, a real pain.
Okay, so how does MedGemma change that game?
Well, it takes a totally different approach. It's built on Google's Gemma 3 foundation model, but it's specifically fine-tuned for medicines. So it's designed to kind of speak multiple medical languages at once: radiology, dermatology, ophthalmology, pathology, and just plain English, too.
Multiple specialties. Wow.
Yeah, and it ingests both images and text, together. Then it gives replies that sound, well, frankly, quite insightful, almost like a seasoned clinician weighing in.
Okay, that's impressive. But you mentioned open source and privacy. What's the story there? That feels key.
It really is. It ships under what they call a permissive license. And what that means for, say, a hospital or a clinic.
Yeah.
It means they can run MedGemma right there on their own computers, behind their own firewalls. You don't have to send sensitive patient data protected health information or PHI out to the cloud.
Ah, okay. So the data stays local.
Exactly. It's built with those real-world privacy constraints baked in from the start. That's a massive differentiator compared to many other AI solutions.
That is huge. So MedGemma isn't just one single thing then. It sounds like it has different versions for different jobs.
That's right. It's more like a family of models tailored for different needs. You've got, for instance, MedGemma 4B-IT.
4B billion parameters.
Yep. 4 billion parameters. Think of parameters as like the connections or knowledge points it uses. This 4B1 handles both vision, images, and text. It's pretty good for lighter tasks, maybe running on edge devices or just quickly trying things out, prototyping. It can actually fit on a single high-end laptop GPU.
Okay, so relatively accessible. What else is in the family?
Then you scale up. There's MedGemma 27BMMIT, so 27 billion parameters.
Yeah.
Also vision and text, but much beefier. Designed for those really comprehensive workflows involving complex images and lots of notes.
Makes sense.
And if you only need text analysis, maybe for clinical reasoning or sifting through long patient histories, there's MedGemma 27B TextIT, same size, 27 billion, but text only.
Gotcha.
And one more, MedSiglip 448, much smaller, about 900 million parameters, and it's vision only. Used mostly for things like image classification or finding similar images quickly, zero-shot stuff.
What really strikes me, though, is you said these are truly open. What does that actually mean in practice? Like, for someone listening, why should they care about inspecting the weights or logs?
It's absolutely game-changing. It means it's not some mysterious black box. You can actually look under the hood. Researchers, developers, even individual clinics can audit it, understand how it works, why it makes certain suggestions, and then build on top of it confidently.
Right. Transparency builds trust.
Exactly. It fosters trust and speeds up innovation in a way that closed proprietary models just can't.
Okay, so for people thinking, maybe I could use this, how hard is it to actually get it running? Is it a massive IT project?
Actually, no. Our sources say it can be remarkably quick, like potentially 10 minutes on the right hardware.
10 minutes? Seriously?
Yeah, assuming you have the right GPU. You need a SUDI-enabled card, which is pretty standard for AI work now. For that smaller 4B model, you need about 16 gigs of VRAM. That's the GPU's dedicated memory.
Okay, 16 GB VRAM. That's doable on many modern workstations or even high-end laptops.
Right. For the bigger 27B models, you're looking at 48 gigs or more. So more demanding, but still within reach for many professional setups.
And once it's installed, using it is about the prompt, right?
Yeah.
Like talking to it.
Absolutely. The quality of the output really depends on how clearly you ask the question. It's all about the prompt.
Can you give an example, say, for a radiologist?
Sure. A radiologist could upload a chest x-ray image. Then they might type in a prompt like, describe any abnormalities observed and suggest appropriate follow-up actions. Pretty straightforward.
And the kind of answer they might get back, our sources had an example.
Yeah, something concise and clinically relevant, like, film shows bilateral parietal otacities consistent with early pulmonary edema, cardiac silhouette mildly enlarged, no pleural effusion. Consider bedside echo and repeat x-ray in 24 hours.
Wow, that sounds useful, very direct.
It is, and the performance numbers back this up. The benchmarks are, well, quite compelling. Take the Chexpert score for chest x-rays. MedGemma 4B hits 48.1. Its base model, Gemma 3 4B, is way down at 32.6. That's a big jump.
A huge jump.
Or on the MedQA score, which is like medical board questions, the 27B MedGemma gets almost 90%, while the base Gemma 3 is around 75.
Okay, benchmarks are one thing, but what about real-world comparisons? There was that anecdote about the head-to-head reading.
Yeah, that was fascinating. They did a blind test. 100 random chest x-rays. Junior doctors read them. MedGemma read them. The doctors missed major findings in 12 cases.
12, okay.
MedGemma missed only 6. But here's the kicker. MedGemma actually caught 3 major findings that all the human doctors missed.
Whoa, seriously?
Seriously. And in 68 out of the 100 cases, it suggested the exact same follow-up actions as the doctors.
So it's not perfect, still missed 6.
Not perfect, no AI is. But it's starting to look less like just a tool and more like a tireless, pretty astute colleague, especially for that initial read or triage.
Okay, that's a powerful comparison.
Yeah.
So how does MedGemma stack up against other medical AI models out there? There seem to be quite a few emerging now.
Yeah, the field is definitely heating up. Broadly speaking, MedGemma seems to offer the widest range of skills with the least amount of friction to get started, especially because of that open license.
Okay, so let's compare. What about, say, Meditron 70B? That sounds big.
It is big, 70 billion parameters, and it's strung on text-based stuff like answering board questions, but it can't read images at all.
No images. In medicine, that seems like a major limitation.
Huge limitation, plus its context window, the amount of text it can consider at once, is relatively small. And the licensing based on Llama 2 can be tricky for commercial use, less accessible.
Right. What else? BioMistral Clinical.
BioMistral is interesting. It focuses on incremental learning and uses something called RAG, retrieval augmented generation. Basically, it pulls in external info to help answer questions.
Okay.
But it's smaller, 7 billion parameters. It needs that external database to work properly, which adds complexity. And crucially, imaging support. It's planned, but not there yet. So still text only for now.
Gotcha. How about PaliGemma too? That sounds related.
It is closer in spirit. Blends vision and language, open weights, similar ideas. But PaliGemma is more focused on things like generating image captions or single-view reports. It wasn't specifically fine-tuned on lots of electronic health records or trained for that deep multimodal reasoning across different specialties like MedGemma was. Its chest x-ray reports aren't quite as clinically detailed.
I see. And you mentioned Google's older model, MedLM.
Yeah, MedLM is actually being deprecated, phased out later this year in September 2025. MedGemma really inherits its best concepts, adds the crucial vision component, and, critically, gives you the downloadable weights.
Avoiding that vendor lock-in.
Exactly. That's a theme we keep coming back to because it's so important for healthcare institutions. They don't want to be completely dependent on one cloud provider.
Makes total sense. What about Hippocratic AI? They talk a lot about safety.
They do emphasize safety and real-world evaluation, which is great, but it's closed source and K-walled. So that limits peer review, makes it harder to audit independently, and you can't run it on-premise for maximum privacy. It's a different philosophy.
Okay, last comparison. How does MedGemma fare against the big general chatbots like Gemini 2.5 Pro or GPT-4o if you just ask them medical questions?
That's a really important distinction. Those general models are amazing, but they aren't specifically trained or constrained for medicine. There's a real risk of them generating plausible-sounding but incorrect or even dangerous medical advice. Medical disinformation is a concern.
Right.
With MedGemma's open weights, a hospital's own team can add custom safety layers. They can fine-tune it on their own data. They can red team it, test it rigorously against specific risks relevant to their patients. You have much more control.
So pulling it all together, the edge for MedGemma is?
It's that unique combination. Strong multimodal skills right away, the permissive open license, that large context window for handling complex patient histories, and the open nature that invites community involvement and scrutiny. It's built for practical, real-world clinical use, respecting privacy and avoiding lock-in.
Let's dig into where this kind of silicon intelligence might actually do things better than a human doctor. What are those unique strengths?
Well, first off, memory. MedGemma handles 128,000 tokens in one go. A token is roughly a word or part of a word. Think about that it can hold guidelines, the entire patient history, complex imaging sequences, all in its active memory for a single encounter. Human memory just doesn't work like that. We forget details, we get overloaded.
Okay, infinite memory. What else?
No tunnel vision. A human expert is typically specialized, right? A dermatologist thinks dermatology, a pulmonologist thinks lungs. MedGemma can switch between these specialties instantly within the same analysis. It might spot a skin finding relevant to a lung issue, making connections a single specialist might miss.
Interesting. And the obvious one.
Yeah.
It doesn't get tired.
Zero fatigue. Peak performance at 3 a.m. is the same as at 3 p.m. Consistency is a huge advantage, especially in high-pressure, round-the-clock environments like hospitals.
And you mentioned bias control. How does that work?
Well, its reasoning is based on statistical patterns in the data it was trained on, which are auditable. While training data can contain biases, they are potentially identifiable and correctable through careful dataset curation and fine-tuning. The goal is to reduce the impact of unconscious human biases by relying on more objective statistical priors, assuming the training data is representative, of course. That's the key part.
So it's adaptable. Can a clinic actually, teach it new skills, customize it for their own needs?
Oh, absolutely. And it's easier than you might think. You don't need to retrain the whole giant model. There's a technique called LoRa low-rank adaptation. It's a very efficient way to fine-tune the model on a specific, smaller data set. So say you have 500 knee MRI reports from your sports medicine clinic. You could use LoRa to fine-tune MedGemma on just those reports, maybe over a weekend, and create a specialized clinical reasoning AI just for knee injuries.
Wow, okay. That's powerful customization.
Yeah.
And deployment. What are the options for privacy-conscious hospitals?
You've got choices. If you need maximum control, you run it entirely behind your own firewall. You can use these optimized versions called GGUF quantizations.
GGUF?
Yeah, they're like compressed versions of the model, easier to run locally. All the data stays on your servers, period. Or if you need more scalability, maybe during peak times, you could use a secure cloud platform like Vertex AI for healthcare. It's designed to handle healthcare data securely and can scale up massively.
So flexibility depending on the need.
Right. And it's designed to work with regional privacy laws, allowing you to strip out identifying information before processing if needed.
Can you paint a picture of how this might work in a real workflow, like end-to-end?
Sure. Imagine an agentic workflow.
Yeah.
Step 1. MedSiglip, the vision-only model, scans a dermatology photo and flags suspicious skin regions.
Okay.
Step 2. Those little cropped patches get sent to MedGemma 4B, the smaller multimodal one, which writes a clinical description.
Right.
Step 3. That description goes to maybe a general model like Gemini 2.5 Pro, tasked with writing a simple explanation for the patient. Step 4. A scheduling agent sees the output, finds the patient needs a follow-up, and automatically offers them an appointment.
And it all gets logged.
Step 5. Everything, the image analysis, the explanation, the appointment offer, gets logged securely back into the patient's electronic health record.
That whole chain happening automatically.
In seconds. Turning raw pixels into an informed action, potentially without any sensitive data ever leaving the hospital's control. That's the promise.
It sounds incredibly capable, but let's tackle the big question. Is it actually better than most doctors?
Better is tricky. It depends what you're measuring. For certain tasks, yeah, maybe. Things like routine pattern recognition, spotting a straightforward fracture on an X-ray, answering textbook diagnostic questions. MedGemma's accuracy is often on par with, or sometimes even better than, the average human clinician.
But not always.
Definitely not always. It still struggles compared to experienced experts when it comes to really rare conditions, complex edge cases, or that deep, nuanced understanding that comes from knowing a patient over many years. That longitudinal, multimodal reasoning is still a human strength.
And what about its role in places with, severe shortages of doctors?
That's where it could be truly transformative. Think about parts of the world where there's maybe one radiologist for a million people.
Yeah.
In that context, having a free open source model that you can run locally that can reliably flag obvious signs of, say, TB on a chest x-ray, that could save countless lives. More lives, perhaps, than an expensive, inaccessible MRI machine. Democratizing access is key.
Absolutely. But we need to talk limitations and safety.
Yeah.
It's not magic, right? What are the guardrails?
Crucial point.
Right.
No AI is foolproof. While MedGemma tries to refuse unsafe instructions, you can sometimes trick AI models with clever prompting, so you absolutely need safeguards.
Like what?
Like a strong governance layer. Every single query and output needs to be logged. Outputs need to be validated, ideally against your own local, trusted data. You cannot just let an AI write a prescription unchecked.
Understood. Any other specific limitations we should know?
Yeah, a few key ones. Right now, it's mostly focused on analyzing single static images, not really sequences or videos yet. Also, its ability to handle long back-and-forth conversations hasn't been as thoroughly tested as its single prompt analysis.
Okay.
And as we mentioned, it's sensitive to the prompt. A vague or poorly phrased question can lead to a less accurate answer. Garbage in, slightly less useful garbage out sometimes. It needs careful handling.
So looking ahead, what's next for MedGemma and this kind of AI?
Well, Google's hinted at bigger models, maybe 65 billion parameters soon. And richer video understanding is definitely on the horizon, which would be huge for things like analyzing surgeries or dynamic scans.
Video analysis, wow.
The community is also buzzing about the growth in open medical data sets, especially in radiology. More data means smarter models. And expect the tools for fine-tuning to get much easier. We might move from coding notebooks to simple drag-and-drop interfaces for customizing these models for specific clinical needs.
So building your own specialized AI could become much more accessible.
Potentially, yeah. Imagine doing it over a coffee break.
It's interesting. Clinicians used to worry AI would de-skill diagnosis, take away the art. But this feels different.
It does. It feels less like a replacement and more like a supercharged textbook that talks back, or an incredibly diligent assistant. It can flag things you might have missed, summarize mountains of notes, help you stay current. It doesn't replace the doctor's judgment or empathy.
More like autopilot in a plane.
That's a great analogy. It handles the routine, acts as a safety net, freeing up the human pilot, the doctor, to focus on the complex navigation, the unexpected turbulence, the human connection, the ethical calls, the messy, uniquely human parts of medicine.
And the open nature of MedGemma really fuels this, doesn't it?
It's transformative. Every medical school, every research group, every clinic with the right hardware can now experiment, iterate, build. You don't need to ask permission or pay huge fees just to try things out. That democratization is going to spark innovation we can't even predict right now.
So maybe 2025 is the year healthcare really starts this partnership with Silicon in earnest.
It feels like a turning point.
So for everyone listening, maybe it's time to think about firing up that GPU, checking out the MedGemma resources. The future of medicine is unfolding right now. And while it might involve Silicon, it's definitely going to need curious, engaged humans steering the ship.